So in neural network, you probably heard that activation functions are important, and if you don't use activation function, everything is going to be linear, it's going to collapse, it's going to be one line, and you won't be able to pick up patterns very well. But what do we mean by that? So for this one, I'm going to focus on Relu and leaky Relu, and I'm going to compare it with not using any activation function. So that means that you are just having a linear relationship between your input and output. Each one of the neurons only have linear formula, so no more activation function. But okay, so let's first graph it so we see how do they look like. When we're talking about the activation function value, the way it will look like is, so for example, I have 1, 2, 3, and then I have, so this is 0, and for here, I'm gonna have, actually hold on, it's a good idea I think it's a good idea for me to show 0 is a little bit higher so you can actually see the line. So if I have 0 here, 1, 2, 3, and then here I'm going to start from, for example, -2, and then here 3. Now this is going to be Relu. My Relu would look something like this. I'm gonna come all the way, it is 0 until I reach 0, and then after 0, I'm going to exactly, for the positive numbers, I'm going to exactly have the same values. So this is going to be Relu, okay? I'm gonna first plot all of them, and then after that I'm gonna explain why does that make a difference. So then when we're talking about leaky Relu, right now, every negative value that I have, I'm gonna get 0 for it. And then every positive value that I have, 0 is gonna be 0. And then every positive value that I have, it's going to be exactly the same value. So it's going to be 0 all the way here, and then after that, it's going to be linear. But overall, when you're looking at it, it is non-linear because this area is not the same number. The negative numbers are not the same. And then, so now, if I want to look at leaky Relu is a little bit different. So now I have 3. Okay, I'm going to, this is 0. So when I'm at 0, I am at 0, right? But now when I have negative values, I'm not gonna be at 0 still. I'm gonna have a little bit like, it is leaky, right? So it is slightly goes down. It's not, the relationship is not 1 to 1, but it is slightly, is a little bit going toward negative. It's not going to be 0, it's going to be a little bit less than 0. And then when I'm going back up here, again, all the values are going to be the same. So the positive ones are going to be the same value, but the negative one are going to decrease a little bit. So there you go. So that's how leaky Relu looks like. And then, oh my God, I made it too big. And then when we are talking about the linear, like if I don't have any activation function, then whatever I get here, like for example, if I have 3, 2, 2, 3, then if I want to plot the linear relationship, that means I'm not using any activation function. That's going to be a straight line. So whenever you have -2 and -2, the values are going to be the same, and it's just like that till the end. It's just going to be a straight line. But these ones are non-linear, even though they look very simple. So they can't really pick up very, very complicated patterns, but they still do better than linear. So it is very efficient for a moderately complex system. They will do good. Okay, now let's look at the application and see why does this simple thing is making a huge difference? Imagine I have a picture of 4 squares. So I want to only recognize the blue squares. Blue squares are important to me, green squares are not important to me. Okay, so if I use Relu here, I can make the greens to be, the value of the greens to be -1. I can represent green ones with a negative number and then blue ones with a positive number. What Relu can do is that whenever you're giving, we can make this even better. Instead of this one being green, I'm gonna make this pink. So I'm interested in blue squares and I don't care about the rest. So what I can do with Relu is able to make anything negative as 0. So it can just not consider those negative numbers. So what happens here is that I'm assigning, when I'm training my neural network, eventually I'm going to assign a negative number to pink and negative number to green. And then when it is negative, it's going to be 0, right? So it's not going to even recognize this green and this pink. What is going to and then I can give positive values to blue and it's going to recognize that there are 2 blue squares here and just completely ignore this green and pink, okay? But sometimes I don't want to completely ignore these 2. I want to acknowledge that there are other squares in this picture, but these other squares are not as important as blue. I'm looking for blue, but I still want to recognize the fact that there are other squares in the picture. But Relu cannot do that because any negative value here is going to be 0. But then if I'm using leaky Relu, you can see that the negative numbers have less importance. They still have something, they still give some values, but they are less important, okay? So for that reason, I'm going to say the blue ones are going to be a positive number and the green and the pink one are going to have negative numbers, but negative is not going to be 0. It's going to have a little bit of value. So Relu is not going to recognize anything else in this picture, and it's the only thing that it's going to recognize is the fact that there are 2 blue squares here. So we are missing information. If it is important for us to know that there are other squares in this image, we're going to have a problem with Relu. But then when we are talking about leaky Relu is going to say, yes, there are 2 blue squares there, but there are some other squares there too. So it's not going to give that much importance, but it's going to recognize the fact that there are other squares there too. So when you have a linear activation or nothing, you can't pick up on the importance of the features. So it's going, because any value, it's going to exactly match the same value as the output, right? So you cannot say, for example, these blue squares are more important than pink and green. It will have harder time to pick up on that. That is why the activation functions are more powerful than linear functions, and they can recognize more complex patterns. So for example, one of those use cases would be when you're taking a picture and you want to recognize, for example, there's a human in that picture, right? So if you're using the Relu, you would probably, if it is trained very well, it would say that, okay, so there's a human in this picture, but it doesn't know anything else about it. So, but when you're using leaky Relu, it recognizes that there is a human in the picture, but it can pick up on the fact that behind it is a park, but it doesn't really care about there are trees and stuff like that because the importance is less. But it understands that if there is a white background, it's going to be different from if you have a park or something behind that person that you recognize in the picture. So reserve more information, lose more information. This one cannot pick up on patterns.